Dear students, from today we are going to start the videos of subject linear algebra. First chapter is vector spaces. Vector spaces, okay. First of all, we see what is vector space. Vector space. Okay. Let V be non-empty. Let V be non-empty set of objects called vector. Means this V be a set of non-empty V be non-empty set of objects means this object is nothing but vectors. Okay. Define two operations. Define two operations on elements of set V called vector addition and scalar multiplication subject to the 10 axioms given below. Okay. For this, let U, V, W belongs to V and C, D belongs to R, or C and D are scalars. Okay. First axiom is the sum U plus V belongs to V. This is closure under multiplication. Closure under addition. Closure under addition. Means what? If you take U and V are two vectors in V. If you take sum of these two vectors, it is again in V. Means closure under addition. Second property is U plus V is equals to V plus U. V plus U. Addition is commutative. Third one is U plus V plus W is equals to, in bracket, U plus V plus W. Okay. Addition is associative. Or associativity of addition. Fourth is a zero vector. 0 belongs to V such that 0 plus U is equals to U, which is equals to U plus 0. Existence of additive identity. Existence of additive identity. Fifth one is for all U belongs to V, there exists minus U belongs to V such that U plus minus U is equals to 0, which is equals to minus U plus u. Existence of inverse element with respect to addition. Note this. This is the existence of inverse element with respect to addition. 6 is C into V is C into U is belongs to V. Closure under scalar multiplication. Means what? If you take any scalar which is belongs to R and you take any vector which is belongs to V, if you take product of these two, this product is in V. This property is nothing but closure under scalar multiplication. Okay. 7 C into U plus V is equals to C into U, C into V. This property is distributivity of scalar multiplication over vector addition. Okay. Eighth property is C plus D into U is equals to C into U plus D into U. This is nothing but distributivity of vectors over addition of scalar. Okay. 9 number property is C into D into U is equals to C into D into U. Associativity. And last one is 1 into U is equals to U. Existence of identity element for scalar multiplication. This is existence of identity element for scalar multiplication. Okay. The set V defined above is called vector space. Is called a vector space. Is called a vector space. Called a vector space whenever the 10 axioms hold good for all vectors. Of V. Okay. That means if V satisfies these 10 properties or axioms, then we say that V is a vector space. V satisfies means what? Elements of V satisfies these 10 properties, then we say that V is a vector space. Okay. V is a vector space over R, because here C and D are we are taking the scalars from R. Okay, let us take one example or see examples on vector spaces. example is let V is equals to R2, which is equals to set matrix XY such that XY belongs to R. V is a set of vectors in XY plane is a real vector space. Solution: V is the set of all matrix XY such that XY belongs to R. V is a set of vectors in XY plane. Is a real vector. Here we can say matrix or vector XY. Okay. So let U comma V belongs to V and C comma D belongs to R, then okay, U is equals to vector x1 y1, because these elements of this set of the form vector xy. So we will take U is equals to vector x1 y1, V is equals to vector x2 y2, where here x and y are belongs to R. That's why x1 comma y1 comma x2 comma y2, these are nothing but elements of R. Okay. Then U plus V is nothing but order pair x1 plus x2. Take component wise addition, and so we will get y1 plus y2. Okay. Now see here, we have to show that this set is a vector space. Okay. For this we have to prove all 10 properties. In 10 properties, first property is closure under addition, means we have to show that U plus V is belongs to this V. Now see here, U plus V is equals to, what happened, x1 plus x2, y1 plus y2. Again, x1 and x2 are real numbers and y1 and y2 are also real numbers. So their addition, x1 plus x2 is also belongs to R, and y1 plus y2 is also belongs to R. That's why this U plus V is belongs to V. Here we can give reason, x1 plus x2 comma y1 plus y2 belongs to R. That's why this U plus V is belongs to V. Okay. Now second property is addition is commutative, means we have to show that U plus V is equals to V plus U. Okay. U plus V is nothing but x1 plus x2, y1 plus y2. Okay. This x1, x2, y1, y2 are real numbers, and in real numbers the addition is commutative. That's why here we can write x2 plus x1, y2 plus y1. Okay. This is nothing but V plus U. Means second property is also satisfied. Now third property, associativity of addition, means what? We have to show that U plus V plus W is equals to U plus V plus W. Okay. So U plus V plus W if we take w is equals to x3 and y3, then we will get u plus, here our u is nothing but x1 y1, okay, plus v is x2 and w is x3, plus what, y2 plus y3, okay. This is equals to, take addition of these two vectors again, we will get x1 plus x2 plus x3. This is nothing but y1 plus y2 plus y3. Again this x1, x2, x3, y1, y2, y3 are real numbers and they satisfy associative property. That's why here we can write x1 plus x2, y1 plus y2 plus x3, y3, and this is nothing but u plus v plus w, means we satisfy third property. Now fourth property is property of zero vector. Vector 0, 0 is belongs to V such that 0, 0 plus x1, y1, which is equals to 0 plus u is equals to u, which is equals to u plus 0. Means 0 vector is also belongs to V. Fifth property is existence of additive inverse. Means what? For all u belongs to capital V, there exists minus u belongs to V such that u plus minus u is equals to 0. Okay. Here u plus minus, for all u belongs to V, minus u belongs to V, where minus u is nothing but minus x1 minus y1, such that u plus minus u is equals to 0, which is equals to minus u plus u. Okay. This is fifth property. Fifth property is also satisfied by V. Next is closure under scalar multiplication. Means we have to show that C into U belongs to V. Okay. C into U is nothing but, C into U. C into U is nothing but x1, y1, which is equals to cx1, cy1. Is this vector belongs to R? Is this vector belongs to V? Yes, because x1 and y1 are real numbers. C is also real number. So C into x1 and C into y1 are belongs to R. That's why this belongs to V. Since cx1, cy1 belongs to R. So we satisfy sixth property. Okay. Now seventh property is C into U plus V is equals to C into U plus C into V. Okay. Let us check it. Seven number property, C into U plus V. U plus V is what? x1 plus y1, x2 plus y2. Okay. So multiply component wise, we will get C into x1 plus C into y1, C into x2 plus C into y2. This is nothing but vector C x1, C x2 here is u plus v is, I have written wrong, this is x1 plus x2, y1 plus y2. Okay, so this will become C into x1, C into x2, C into y1, C into y2. So this is C into x1, C y1 plus C into x2, C into y2. Take C common, x1 y1 plus C into x2 y2. Okay, so we will get, this is C into u plus C into v. Hence v satisfies 7th property. Now 8th property is C plus D into u is equals to C into u plus D into u. Proof of this property is similar as of 7. So this is a homework to you. Prove this. 9th number property is C into D into u is equals to C into D into u means what? D into u is x1 y1. Okay, which is equals to C into dx1 dy1. Okay, multiply C throughout the vector, we will get C into dx1, C into dy1. Okay, now take this C into D common outside the bracket, so we will get C into D matrix x1 y1. This is nothing but C into D into u. Okay, hence 9th property is satisfied by this vector, this v. Now last one is 10th property. 1 into u is equals to u means what? Obviously 1 into x1 y1 is equals to x1 vector x1 y1, which is nothing but u. Means 1 into u is equals to u. Means existence of identity element for scalar multiplication. Hence v satisfies all 10 axioms. Hence V is a vector space over R, or V is a real vector space. Okay, we will stop here. Thank you.